Good evening, ladies and gentlemen. This is going to be experiment number 9 in the book, our second to last experiment of the semester. And we're going to learn a technique called column chromatography, and we will be doing some more extractions. We have been, this time in our scenario, we're wanting to know how much lycopene, not how much lycopene, we want to know how much the lycopene that is in tomato paste, which we will extract from the tomato paste, it comes in two isomers, and one of those is a trans. All the double bonds in the lycopene are, here's what lycopene looks like. This is the all trans version of it. There is a version of it, and we may not have it in here. We do not. That is, you can see that in your book, and that one is at this position right here. There will become a cis isomer of it as opposed to the trans isomer here. So we're not sure. We know that in plants, it comes in this form, but in the body, lycopene's converted to that cis isomer. So the question is, which version is more important to the human body? So what we're going to do is just to see, does it stay in this form in tomato paste, or does the processing convert some of it over to the other type anyway? So the way we will extract, we will just do an extraction. You'll take some tomato paste and you're going to add a mixture of materials to it. It's going to be a combination of acetone and something called petroleum ether. And it's a very low boiling point petroleum ether. So what will happen will be when you extract, you'll just mix your petroleum ether with this, and through a little process that we'll talk about here in a minute, you'll extract out the tomato, the lycopene from the tomato paste. You'll do a series of washings because acid will break it down. We're going to get rid of acid, and we'll do a whole bunch of other things to it. And then we'll concentrate it, and you'll end up with this concentrated lycopene material, which you will then put on the column, and I'll show you how to do the column chromatography here as well. I'm going to give you a video to watch on the column chromatography. Here is experiment 9, isolation of lycopene from tomato paste. So it's only a 7-minute video. I recommend you watch it highly because this person goes through with you pretty much what we're going to be doing. They do a couple steps different than we do, so don't write down all of her steps because ours will be slightly different. Now, column chromatography essentially is going to use this as it looks. It's just a column of glass. It looks like a burette. The problem with ours is we don't have this valve on it. Ours, there's just a cap. So you'll have to just let, yours will drip at a nice steady rate. You just have to put the cap on it when you don't want something. It works very well. But a common chromatography column looks like this. We can look at one. And you can see that what you have in it is there'll be a glass wall you put in it to start with. We will not do that. Ours has what's called a frit in it, and it is a already permeable membrane, so you won't have to do that. And then you'll have to put in your adsorbent, which yours is going to be a material, aluminum oxide material. Brockman 3 is the name of it. And then what you'll do is, this is way too much material. What you'll do is put your material on top of this. That'll be where your lycopene will go. And by the way, this adsorbent, you will load it with solvent. And then solvent will push your material down through the column. And the thought process there is, if you had a material that was mixed, if we look at this series, here's a mixture of materials. There's a certain polarity to the adsorbent, and that different materials be attracted to that column of material to different degrees. So as the solvent pushes them through, they begin, we hope, to separate themselves from each other. And you'll end up with different bands that you can collect at different times. You'll physically be able to see those bands. We'll be collecting lycopene and beta carotene. Beta carotene's yellow, and the lycopene is red. Now, both these are going to show up in the visible region, although they will have aspects of their spectrum that show up in the ultraviolet region. So any column chromatography method uses this, and you can see all kinds of different ones as they go through. There's all kinds of pictures on the internet of those, and you can see how those things work as you see them there. So column chromatography uses the fact that different materials are attracted to the column, the adsorbent material, to different degrees, and allows them to move at different rates as solvent pushes them through. Obviously, they have to be soluble in the solvent or they would not move through the column, but they're held back by the polarity of the column, and that's what allows them to be moved down the column at different rates. If you read Operation 21 in the back of the book about column chromatography, and I do recommend you read that as well, what you'll find out is that they recommend that your height of your adsorbent material be 10 times greater than the width of the column. I measured the columns the other night, and they're about 1.5 centimeters. So you're going to need about 15 centimeters of absorbent. So measuring up from that frit, you'll want about 15 centimeters. It isn't going to hurt to have a little more, but don't have too much because your materials will never get down the column in any reasonable amount of time. So you don't want this thing too tall. I mean, you could do it, but you need an unlimited amount of solvent to do that. And you know, here's a nice picture of a column here where different things have been separated in it. So there is one aspect of this that I did leave out, and that is whenever you're building your column, there is one other aspect of it, and that is you do want, they talk about cotton down here. We don't have to worry about it. We don't have to worry about it. Some people use glass wool, cotton, sand down here. I think the woman in the video is going to put a little extra sand down here, and she's going to be different than us. We're not going to use the glass wool and the sand. We'll just use our frit. But once you put in your adsorbent, you're going to need to put in a small, and she says about 1 centimeter of sand. That's about a good number, centimeter of sand. What that will do is, this stuff's so fine in here, as you pour liquid into it, it will try to blow back up on you, and the sand is dense enough that it'll hold your column. This column has to be packed perfectly. If this column is not packed perfectly, you'll get really lousy results in your separation. You should literally see these bands move in band type structures. You don't want something that's, you know, at an angle or like that. You want to see these, if it's working properly, you will see bands of material as they move through. So that's the majority of the aspects of those things. When we look at that, I'm going to go ahead and stop this video, and then I'll get into the details of the actual experiment. So join me for that second part.